Three, four, five, and we are live. Hello, everyone. So, uh, hello, good afternoon. My name is Andrew. I'm founding partner of 345. I'm CEO of Blue, which is the encyclopedia for everything in the world of cryptocurrency, which is launching it going into beta in 2 weeks' time. Very exciting. Normally, 345 Tech Talks are a chat between me and my buddy and CTO, Paul. Paul isn't here, so I'm on my own. Paul is in Canterbury, which, as we all know, is the county town of Kent, and he's having a long weekend away. Many apologies to everyone for not getting the podcast out last week, because I was away. I was away at a conference last week, but Paul's away this week, so I'm ploughing on my own. So it won't be the normal format where I say to Paul, and what about this? And then he spends 5 minutes answering it, and then I say, and what about that? And he spends another 5 minutes answering it. I'm actually going to have to talk, which is a challenge I think I'm up for. So, without much ado, let's get on and just say what we're going to cover in this podcast. So really, what we've been doing so far in the 345 Tech Talks is picking a bunch of topics that are important topics and talking around those. What I wanted to do today is to provide a bit of context over the top of that. So what is it about those topics that makes them relevant? And so there's a couple of things that I wanted to go through. So the first one is just really talk a little bit about 345 in terms of background and where we're coming from as people or as technologists, however you might want to call that, so that you might understand why it is that we've chosen the things to talk about that we have chosen. The next thing I'm going to talk about is really that the main pillars as I see it, what they are, and then it'll all make sense, or it might not, but we'll give it a try. So what's the worst that can happen? It's Friday. It's Friday afternoon. It's freezing. It's April the 12th, and it's freezing. What is going on? Something to do with polar vortex. However, spring is around the corner, and it's happy times. Okay, so 345. I mean, 345 really is born out of So myself and some of the guys formed 345 a few years ago. We all used to be on the same product team at Microsoft, and we used to specialize in what at one time was called straight-through processing, STP, sometimes called business process management, BPM, sometimes just called integration, sometimes just called business process orchestration. Lots of words for the same thing, but effectively, something happens and a business process is kicked off, and you try to process as much of it as possible in an automated fashion. And we did that for many, many years, both before we went, individually before we went to Microsoft, and then we were all on a kind of a special project over there as subcons doing that. And we decided after that to continue our good work, and so once it was 4 or 5 years ago, we founded 345, and we've been going as a happy little family ever since. But the real core of what we did was really around integration, and way back when when you started to get systems to talk to each other, you used to be integrating with whatever it was, whether it was text files in a folder or communicating on some weird TCP protocol or whatever. And we then went through a process that, wouldn't it be great to put web services on things? And so, so people started to build web services to their applications, which, service-oriented architecture part 1 or Mark 1, it was really just, you still had monolith applications. They just had web services on them. which effectively made them easier to connect to, but it didn't solve the monolith things. So what happened a bit later on is that we started becoming interested in microservices architecture. So a business process that strings together a number of different units. Each of those units, if you make them atomic, that then tends to become a microservices type of architecture where each service is self-contained, has its own data, is its own unit of deployment. And so so we got into microservices in quite a big way after that as a natural thing from integration. And because we were kind of into microservices and a lot of that sort of thing, we then also got involved in IoT. Not just because a lot of the technologies, a lot of the things that we were doing in microservices was readily transferable to the world of IoT. So if you don't know what IoT is, IoT is Internet of Things. And people that say, oh, IoT, Internet of Things, and everyone's nods sagely, Internet of Things, that's really useful. What does that mean? And it's all down to the fact that we are in a connected world. That all sorts of things now can connect over the internet and send data and receive data in a way that they couldn't do before. And some of those things are really, really, it can produce really, really amazing results. So just some examples of IoT. So, I mean, firstly, you can put sensors in trucks. Also, vehicle tracking is an example of it. Where's my vehicle? And you can find out where a vehicle is, how fast it's been moving. That's like people that have a black box for their insurance. That's IoT. So their car is constantly transmitting its GPS location, its speed, or really just time and location. You can derive speed from that. They are and you can have millions of cars with a box in them that's got a little SIM card, connects to the internet, and transmits speed, location and time in packets of data, and then a centralized process hoovers up all that data and then derives stats from it, of which can affect your insurance premium. Sat navs can be a similar thing. That if you use Waze as a sat nav, Waze gets its data from Google. Now everyone that's got a Google phone or a phone with a Google app on it, those phones might be quietly transmitting your location and time, and from that Google can tell whether you're moving or not, how fast you're moving, and if your position is on a motorway or a main road, it'll say, on that road the traffic seems to be going at this speed, and then use that as data for speed. So IoT is, I mean, particularly with smartphones and devices, it's really big because of the data you can get from smartphones, but also because you can get a device that is that big and it can have a SIM card in it and a sensor, and it can connect over the internet to tell something. So IoT is just what characterizes IoT really is that you have a huge number of huge numbers of devices transmitting what tends to be relatively simple and small amounts of data, but the aggregate of it is very big data because of the number of devices that are out there. So you only have to have, so let's say you've got a meg of data from a device, but you've got 100 million devices. Well, that's a serious amount of data every day. And the things with IoT is that you've got to process this data. You've got to upload it. You've got to process it, and there's then what do you do with that? Do you just use it for insights? Do you use it for alerts? Do you actually action it? Do you make things happen as a result of it? So we got into IoT anyway. We got into IoT in the oil and gas industry, and that's been that was our first IoT use case, and since then there's been lots of other things that we've kind of been looking at for our IoT stack. So great stuff there. So in terms of where we've the things we've been doing for the last 5-10 years collectively as an organization, automating business processes, number one. Number two, microservices. So breaking up an organization's logic into units that are reusable and independently deployable so that you can improve the development lifecycle of those pieces. Number two. And then number three, IoT. So those are kind of the big three kind of technology areas that we've been involved in. So really real depth of usage in those areas. And then if we look at so that's kind of technology areas. And then if we look at use, the what I call the pillars. So we have three pillars. You might notice a theme here. They've got three technology areas. That's a bit of a coincidence, but three pillars. So the first one is method. How do you go about the practice of building software? How do you do that? What is there is the method, and we've been doing software either from hands-on programming, managing, leading teams, technical leadership. We've been doing that for a long time. In Paul's case, he's been doing software for 30 years. I'm relatively new at this because I've only been doing it for 20 years. We've distilled a lot of the lessons from that into method, and so we have the 3-4-5 method, which you will have seen in previous episodes. So we've done a couple of episodes touching on this, but one of the things we often refer to is the 7 outcomes, which if you cannot define success, you cannot be successful unless you first define what success is. Otherwise, you're like shooting arrows, but you haven't got a target. There is, you may hit the target, but if you haven't got something to aim at, it's highly unlikely. So we've got the 7 outcomes, which is really how we know what we're aiming at, how we know that we're successful, and then we've got the 6 strata, which are the 6 areas related to envisioning, building, deploying, and operating software. That if you cover all those bases, you've pretty much covered it. Doesn't matter, you don't have to have a it's not related to a process. It's not like, oh, you've got to use Scrum for this, or you've got to use, TDD, or you've got to use Waterfall. We focus more on practices because if you are doing the right practices, if you've got the right people doing the right things, the process really is the coordination of that, and it becomes relatively, if you've got the right people doing the right things, then you're 90% of the way there. So we're quite flexible on process, but not on practice. You've got to be doing the right practices. So the first thing is method. First pillar of 3-4-5 method. The second pillar of 3-4-5 is, we could loosely call it automation. But that's where all things like DevOps come in, automating processes. We've talked before about the, automation helps remove the toil and the drudgery of repetitive tasks. It's also a prerequisite for quality because, manual processes aren't repeatable, and without repeatability, you can't have quality. So automation is a vital thing in ensuring quality, but also in ensuring that people are free from toil. Because what is it that, ultimately, as humans, what is it that's important that we do? And what's important is that we apply our ingenuity to solving problems. That is the big thing that, that humans are really, really valuable for. Doing repetitive tasks, you can do that with a robot. But actually imagining a better future is something that humans are exquisitely good at, and also that humans find really rewarding work. I've been reading a book uh, and it is called Drive by Daniel Pink. Now let me just get that up. Oh, I should have been prepared for this, but here we are. Here is a quick view of it. Daniel H. Pink Drive. There we go. It's a fantastic book in that it focuses really on motivation for people, how to motivate people, and in particular, it talks about motivation or the ways that companies motivate people in a bit like an operating system. So motivation 1.0 is making sure you've got your physical needs met. You've got enough pay to get by, you've got a roof over your head. Without that, you aren't off the ground. And then it says motivation 2.0 is really about carrot and stick. That, imagine, this goes back to, I don't know, Industrial Revolution. You've got factories and, you've got a factory that makes widgets. You want it to make more widgets. And as long as the widgets are good, the more widgets you can make for a certain number of people, the more profitable you'll be. And so you can afford to give people a carrot for making more widgets. And if they do something wrong, you punish them. And, and for relatively automated stuff, carrot and stick, this is kind of works. Doesn't necessarily make people feel good, but it kind of works. That if you know that if you work that bit harder, you'll get more reward, then you can work that bit harder. If you're like, shall I go for a fag break or make a widget? I'll make a widget because I get more reward. That works. But then you get motivation 3.0, and that's like intrinsic motivation. And this is high, because this is all Maslow's hierarchy of needs stuff. So really, motivation 1.0 is the bottom of the pyramid and Maslow's pyramid, and by the time you get to motivation 3, intrinsic motivation, that's the need to move towards self-actualization. That is what is it that I'm interested in? What is it that I can do that actually expresses myself as a person? And a lot of technical people, this is both like software engineers, but also like mechanical engineers or other type of technical people, they express themselves through what they do. They express themselves through ideas and and making solutions. And a lot of, as we all know, a lot of engineers are on the, shall we say, they're the analytical type of personality. They're the thinkers. They don't always say a lot, and they don't always show an awful lot of emotion, but they are very, very, generally speaking, engineering type of people and the analytical personality. They are actually very passionate, very creative people, but they just don't necessarily express it by gobbling off all the time. And in terms of motivating developers, that actually they need, this whole thing of back to automation, freeing people from the drudgery of repetitive tasks and letting them sort of create stuff that solves problems. That is kind of where really good software engineers want to work. And so not only is it good for productivity, quality, but actually to get the best people. If you want to have a software team with the best people, then you want to give them a decent amount of money so they don't have to think about money, but then just let them put brain power into solving problems and get out of the way. That's that's really that's a really important thing. So automation helps there, but it's a really kind of important area in just getting stuff done, getting amazing stuff done. You need good people. You need to keep them. You need to get them doing the right things that satisfy them. And if you've got really poor processes and a lot of things are manual, and you get people that have got to do manual deployments and run this wisdom, tick, 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 next, 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 put the CD in, tick, 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 next, next, next. What sort of people are you going to be? What sort of people are going to stick at that sort of job? Are you going to get good people, or are you going to get the people that whose brain is elsewhere? Yeah, so really, come on. We all want to have good people in our organizations, and we want to have high productivity, and we want to have people doing amazing stuff and feeling really good about it. And to do that, one of the things you need to do is automation. And so the automation pillar, for many reasons, the automation pillar is a big one for us. So, 3 pillars: method, pillar number 1, automation, pillar number 2, and pillar number 3 is technology. And we often express this as stacks, because what we and we kind of got this off StackShare, really. If you've ever been to StackShare is an amazing thing. Look up a company and see what their stack is, because they actually will have, they will have. Chances are, if it's someone really interested, they'll have a stack on there that says what their technology is. And you can look at like the Netflix stack or the Spotify stack or something like that, and see what they build on. So excuse me a moment, I'm just going to have a slurp of tea. So we have our own stacks. We have. Okay, given the fact that if you are building software right now, you would not. You seriously would not build your own data center. It's just, it's simply not worth it for a whole variety of reasons. There's the time, the capital involved, and the fact that ultimately the people that build cloud platforms, we're talking, and whatever the cloud platform of your choice is, I'm not here to tell you which cloud platform you should use, but the big ones are obviously Google Cloud Platform, Amazon AWS, and Microsoft Azure, however you want to pronounce that shade of blue. Seriously, does your company have the capability of building data centers better than any of these people? And unless okay, if you're Rackspace, you might say, oh yes, I think we do. But really, if you're a normal company, the answer is no. Right? Just go, go home, have a talk to yourself, and then realize that you should not be building data centers. You should be, because building a data center does not differentiate your business. Building a data center in and of itself does not do anything for your business, especially if you're not doing it as well as other people. So all it ends up doing is probably making you less secure, consuming cash and capital, taking time, and you could be putting all of that into the stuff that really does make a difference for your business, which is solutions. Which is how do I make how do I make a software architecture that beats my competitors, and how do I modify that and make that do all the agile change for that. That means that I've got an advantage over my competitors, and that's an important thing. So given that, okay, little lecture on cloud and opportunity cost there. But the point being that everything really that we're building now is cloud, and as you've no doubt heard from the previous podcast episodes, everything that we're building is we use Kubernetes as a foundation layer, because that means that we can run that anywhere and it behaves the same. We can run from a developer's dev box through to testing, integration, staging, and performance up to production environments. And it's the same if we want to run stuff we use AWS as for our own internal platform. However, if which cloud platform you choose is probably as much a reflection of the commercial relationships you've got with a particular vendor as anything else, rather than technical. But whether it's Google, whether it's Amazon, whether it's Azure, or whether it's someone else, if we're built on a Kubernetes stack, you can run it there. And there are some minor with minor tweaks, but it's pretty but the portability is there, and the fundamentals of working with that stack are there. So in terms of stacks, cloud, Kubernetes, and then whatever goes on top. And so we look at so our third pillar really is the stacks, technology stacks. And so that is, if we look at what we've done through that, then we're either talking about method, how you can build software better, how you think about building software, how you define success, how you define outcomes. And then there's the automation of making sure that we've got the right repeatability, the right productivity, and a lot of our DevOps stuff fits in there. And then we've got the technology stacks. What are the tools we're using? Why are we using them? How can we get the most out of them? And that is the stack thing. So those are the kind of three big pillars of what we're doing. So through that, that's a very so just summarizing where we've come from so far. Okay, in terms of solution areas, in terms of the kind of problems that we tended to solve, straight through processing, business process automation, number one, number two, microservices, number three, IoT. And then the way that we approach that, we approach that by, first of all, making sure that the method is right, the method for delivering software is right. Number two, that the automation is in place, so that we've got so that the software and robots are doing the things that they should be doing, and that people are doing what they should be doing and getting the best out of each. And then number three, making sure that the technology stacks are in place, and how to use them, how to get the most out of them in order to build all this amazing software. And that's what and that's what we do, really. 3, 4, 5. It's just how do you build software faster and better? And that's what we're here to continually help with. And we're so it's such an important thing doing that that's why things like the podcast and the blog and that sort of thing. We are interested in sharing this, because it's not going to change the world if we keep it secret, is it? But the more that we can feed that back into the community, the more that the more we can help people pick this up and use it, and the more we can then help in turn change the world for the better in our own small way. So 3, 4, 5 tech talks and the all this stuff is just really is our small way of trying to get this stuff that we believe in out there in the world. Okay, so given the fact we've got that, then let's have a look at so we can recap on where we've been and just place that in a bit of context. So looking at, flipping over to the browser now, episode 1, tracing and debugging microservices in Kubernetes. This was we acknowledged it at the time, but this is a funny place to start, because it's a deep dive on a really technical, difficult area. However, we started here because based on the blogging we've done in the past, tracing and debugging microservices was what we'd had the most hits on. So it made sense for episode 1 to be on the topic that had the most hits. So So we started there. When you're doing microservices, you've got a load of atomic microservices, but they all participate in the business process. How do you diagnose what's happened? And that in itself is a really big problem. We've done we've got many years of solving this. So that's that was the first episode, deep dive, but really kind of about exploiting technology stacks. The second episode, from yes SQL to no SQL. Again, given the fact that a lot of the software we're building now is obviously it has to be resilient. It has to be very, very fault tolerant, and NoSQL databases give us a lot of solutions in this area. However, they do require a different paradigm to use them. One of the things that SQL gives you, which is the kind of the strong suit of SQL is you get the kind of the atomic transactions and you get data consistency. And so, given the fact that SQL gives you those things, so many people from so many years were kind of locked into, okay, I use a relational database with transactions, therefore I've got all this transactional consistency of my data. Doesn't scale, but it's really transactionally consistent. And whereas moving to a NoSQL is just it is a very different way of thinking about a lot of these things. But if you want to do software at scale, you have to get your head around that. So so episode 2, from yes SQL to no SQL, it's really just trying to take people on that journey from SQL to no SQL in the way that a lot of the people we work with, we've had to go take them on that journey as well. And so that was a really important episode for us to do. Episode number 3, fundamentals of Kubernetes. Well, like we just said, Kubernetes is like a core part of our stack. So again, another real part of the stack pillar is Kubernetes. Just what is it? What do you have to do? What do you have to know? Paul is amazing at Kubernetes, but we also have a whole load of other people that we both in 345 and partners we work with that are also really knowledgeable, that the information rubs off. So if you're on a Kubernetes stack, or if you want to start with Kubernetes, look at that episode. That's a really great place to start. And then we started talking about method for a bit. This was just an opportunity to really to give Paul a break and to start sort of getting me to talk about some things, because a lot of the method type of it is really the area that I focus on a bit more, whereas a lot more of the technology stack items is Paul. So episodes 4 and 5, 7 outcomes for success in software development. I mean, if you want to be successful, you need to define what success is. And in terms of the 7 outcomes, what we try to do is we try to say, okay, when people focus on one particular area, they tend to lose focus on others. And so by having 7 outcomes, we've got a broad range of outcomes that we want to be successful across all of them. And by doing that, we can make sure that we don't penalize ourselves too much in one area. So for example, we've worked with clients before where security is such an important thing. I mean, security is always important. But if you go over the top with security, your security teams can prevent anything else from happening. And so you don't, similarly, if you try to cut costs, you can penalize availability. If you want to, if you want rapid delivery, sometimes you can cut corners and compromise quality. So our 7 outcomes: rapid delivery, quality and bug-free, available and scalable, secure, functional and lovable, cost optimized, and standards compliant. If you've got a good score across all those areas, then you've got a balance in your priorities. If you've got some that are particularly good and some that are particularly weak, then what that does is it highlights to us where we should be focusing our efforts in order to make sure we're getting the best outcome. So that really is the the 7 outcomes for success episode, and that came in 2 parts. And what we did then was moved on to 10 principles for DevOps. Now, obviously, DevOps is all the automation stuff. So 10 principles for DevOps is a fantastic couple of episodes. Paul has done a huge amount of thinking to really delve into that and to think very deeply about what are the fundamental things or the fundamental ways you need to look at your DevOps. And so, episodes 6 and 7 are the deep dive on that. They are really, really kind of landmark episodes. Just if you haven't listened to them, or even if you have listened to them, listen to them again, because what is encapsulated in there is really, really deep stuff. Episode 8, our DevOps stack. So that's after having sort of said the approach to DevOps, we talked a little bit about the stack that we use to put that into place. And so there's 3 episodes there are very much on the automation. Episode 9, how to deliver a Kubernetes microservices platform. This is kind of a stack one and kind of an automation one. It's a bit of the two. So given the fact that we've talked now about how amazing Kubernetes is, and how amazing our technology stack is, and all these problems it can solve. Well, okay, so let's say you right now say, okay, that's really good. That's exactly what I want for my organization. Well, what do? You can't wave a magic wand and have that stuff. You've got to go through you've got to go through a particular series of steps in order to get that in place. And so that episode is talking about how you go about putting that stack in place. In particular, I mean, we look at software delivery in a. Let's try and do this on the fly. This is me. Everyone's getting a good view of my kitchen here, by the way. So if you are on the audio version, you probably won't notice any difference. If you're on the video, it's like, oh, there is Andrew's kitchen. Yeah, so my laptop is just running out of power, mainly because it's I imagine because doing doing all the recording is probably burning more power than it's used to. Okay, right, sorry about that. We are now back. So delivering a Kubernetes microservices platform. So this comes from real life problem in that people do come to us and say, all that Kubernetes, all that Microsoft stuff, I want that, and can you give it to us? And so we've done this a few times now, and so we've distilled that information down. So for this episode is the sort of the first 2 items of the Kubernetes platform, which is defining what you want, and then delivering it as a usable platform. And then we've got the next episode that follows on from that is really how you exploit that. So okay, you've deployed a platform, but then it's really how do you make the best use of that? What are the patterns, practices, the principles, the procedures, the processes that exploit that to its fullest, and then how do you maintain it? So episode 9 is the define and deliver episode. Well, this is episode 10, so episode 11 is going to be the exploit and maintain parts of Microsoft's microservices platform. So there's a little preview. So I've talked a bit, obviously, about what we've done and where everything fits in. So just also want to give a bit of a preview as to what happens next. So the things that are coming up, obviously we've talked about. Next episode will be how to exploit your Kubernetes microservices stack. But after that, what we haven't talked about much, that we will start to talk about, is IoT. Fundamentals of IoT. What is it? What are some of the case studies for it? What are some of the things you can do with it? How is it changing the world? And then we'll look at our IoT stack. So what do we put in place for IoT in order to make it work? And after that, we will be looking at, how to deploy that stack, how to exploit it, all sorts. There's a whole ton of IoT that we'll get onto, but also again, given where it come from, a lot of it's kind of back end processing, but we are going to talk a bit about front end. So we've got a lot of single page applications that we're doing at the moment that's really, really exciting. So it's not just is it Angular, React, or Vue, which is the best one, but also how do what are some of the big things you want to be doing with that? So, WebSockets, so opening up a connection to your cloud platform and messaging to it. How to publish that in a CDN, a content delivery network, so that it's really performant. How do you version single page applications? Because obviously, if single page applications aren't like a server side application where you're always posting back and getting a fresh web page. You can get an application that loads in your browser, and it could be there. It could literally be there for weeks without needing to be refreshed. What happens when you refresh it? What happens if the server side is refreshed and you haven't refreshed your client? Now, if you're not doing that properly, bad things can happen, and can happen quite quickly, particularly if you've got an approach of kind of continuous delivery. So there's a whole load of things around single page applications that we're going to talk about. In particular, versioning, publishing, WebSockets, and again, logging, tracing, diagnostics, monitoring of your users, analytics, a whole load of things in there on the front end that go with single page applications. And that's really a little bit of a preview to where the next 2 or 3 months is going. So, apart from that, I'd really like to thank everyone that's been listening to 345 Tech Talks. We have had, much more of a reaction than we thought. Just people from all over the world. All those people in Utah, thank you for listening. And California, we're just we're based in the south of England, and we just kind of bumble along doing our own thing. And it's amazing that people all over the world are listening to 345 Tech Talks, which is just me and Paul just bumbling on about what we're doing at the moment. So really thank you all for that. And Paul will be back next week. I'll be back in the office next week, and we'll get back on to sharing tech stacks and tech talk with everyone. So in the meantime, thank you all for listening. It's been immense, and we'll catch you soon. Bye now.